Alrighty, okay, students, how you doing? Hopefully you guys had a good day today in school. So this is going to be the video for today that'll help you guys out with tomorrow. Alrighty, and this is coming out of the course workbook, and this is dealing with section 1. We are going to go to topic 9. Okay, so section 1. And this will be topic 9. And this is about operations on polynomials part 2. Okay. We're gonna do part 1 on Friday. Again, on Thursday, we're going to be doing a test, the NWEA test. But on Friday, that is when we'll actually be coming back to doing this. Okay, or maybe not on Friday, but the following week, because you may have a quiz on Friday, so just keep that in mind. Not only are you going to have the NWEA test on Thursday, but you might also have a quiz in my class on Friday as well. Okay, this is on operations on polynomials. Okay. This will be coming from page number 23. And this is in the course workbook, okay? Alright, so let's go back to elementary school right quick, or middle school. So let's say I had a rectangle, okay. And let's say this rectangle was 2 feet, and let's say this was 7 feet. And let's say I asked you for the area of the triangle. I'm sorry, or the rectangle. So what is the area? Remember, the formula for the area of a rectangle was length times width, right? And so in this case, this would be the width, this would be the length of it, or you can say length and width, doesn't matter how you want to do it, but I say width, and this is how long it is. So this is going to be 2 times 7, okay, which is going to be 14, right? Now, let's say, for example, let's say we had a box, and with this box, this is a 1 by 1, this is a square. Okay, 1 by 1. Okay. So the area of that, of course, is still 1, because when you multiply 1 times 1, you still get 1. Now let's say we had something else that had a length of 1, but a width of x. Okay. So this is 1 by x, right? So let's say we had 2 of these, right? So if I had, that'll be that one, and then this would be another one, right? Now let me put them together. This is still the length of x. This is the length of 1. This is another one right here. Okay. So how will we find the area of this whole thing? Okay. Well, the area of this whole thing right here, well, you have to add up this one and this one to see what that's going to be. So that gives you 2, right? And it's still x. So the area of this one is going to be 2 times x, which is just 2x. Correct. And then if we added another one, it'll be 3x, and so forth and so on. Right. So this is what we're going to get into. We're going to get into area models and the distributive property, or multiplying polynomials. Okay. So So the first question asks you, sketch a diagram of algebra tiles that represents 2x plus 4. Okay, 2x plus 4. So we know that this is going to be, so we want to do 2x plus 4, right? And you are dealing with something that's just, this is a 1 by x. Right? So if we had to do 2x by 4, or 2x plus 4, well, we know that if this is 1x right here, if this is 1x going this way, then we have to draw another one to represent 2x. Okay, so it's 2x's. And since this is 1, we might want to draw another one. No, we're not going to do it like that. What we're going to do is we're going to draw a box that goes like this. Okay? 1, 1, 1, 1. So in that case, well, let me see. All right, so sorry about that. I actually made a mistake. So here's the thing: we want to represent some algebra tiles. Okay, so we want to represent constants, and we also want to represent variables. When you represent a constant, we're just going to draw a regular square. And remember, when you have a square, all the sides are the same. So let's say this is a 1 by 1. Okay. So the area of this square is still just going to be 1. Okay. Now let's say I had something that was, it was 1 in the length. Let's say we didn't know what the width was. Okay. So if I ask you for the area of that one, well, that'll be 1 times x, which is just x. Okay. So this long one's going to represent our variable x. These squares are going to represent constants. Okay, and we can add them up. Okay. We can also have different kind of constants too as well, just in case. So let's say we had one that was orange color. This is still 1 by 1. In this case, we're going to represent this as a negative 1. Okay. But this is going to be our negatives. Okay. So it's going to be a negative 1. Okay. So orange is going to be negative, black is going to be positive. All right. All right. So first question asks you to sketch a diagram of algebra tiles that represent 2x plus 4. Okay. 2x plus 4. So we're going to have 2 of these plus 4 of these. Okay. So this is going to be 1x. It's going to be 2x. And then 1, 2, 3, 4. That's how you will represent it. Okay. So x, 1, 1, 1, 1. Okay. So this represents the 2x plus 4. Right. Let's say we had to represent for part B, it says sketch a diagram of algebra tiles represent 3x minus 5. So we're going to have 3 of these, but 5 of our negative ones. Okay, so this is going to be 1, 2, 3. Okay, and one, 2, 3, 4, 5. Okay. We draw a line to distinguish between one problem and the other problem. So this is going to be our representation. This is going to be x here, x here, x here, and this is negative 1, negative 1, negative 1, negative 1, negative 1. This is going to be a representation of 3x minus 5. Okay. Pause the video if you want to replay it back again to see if you can try to understand it. Again, we're just taking basic algebra tiles and applying them to polynomials. Okay. But we're taking it kind of from the basic form and then we're going to build it from there. Now, if you flip the page to page 24 in your course workbook, it says using algebra tiles, the area model below, the area model below models the multiplication of two binomials. Okay, so the top row represents one of the binomial factors in the product. The first column represents the other binomial factor in the product. Write an expression to represent the product of the two binomials. Okay. So let me go ahead and erase this part right here. Again, I come out of the course workbook, and this is on what I answered just now was on page 23, and I'm getting ready to hop over to page 24. Let me start this over. Oh no, let me start it over. I'm good. Yeah. So that was on page 24. So here, so it says using algebra tiles, the area model below models the multiplication of two binomials. Okay. And so right down here it says write an expression to represent the product of the two binomials. Okay. It says the top row represents one of the binomial factors, so this part right here. Okay. And the first column represents the other binomial factor in the product, which is this one right here. Okay. So write an expression to represent the product. Remember that word product. What does product mean? That means multiplication or times. Okay. Other two binomials. So how many x's do we have here? We have one x, and then how many constants? 1, 2, 3, 4. So one of the factors is going to be x plus 4. Okay. And the other one right here, this is x, and then how many do we have here? We have 1, 2, 3, 4 as well. So this is also x plus 4. Okay. Another way of saying this is that once you notice that they are the same type, okay, if I had a times a, it would be a squared. So this is x plus 4 times x plus 4. So this is the same thing as also saying x plus 4 squared as well. Moving along, right down here, it says in the diagram below, the area inside the black square represents the product of the two binomials. So we're still working with the same binomials that we had before. But we're just talking about this part, though, okay? What you get as the actual answer. So it says complete the table below with the number of tiles inside the black square. So how many x squared tiles do you have? Okay. Well, this is the only one that you have here, so you only have one of those. Right. How many x tiles do you have? Okay. And those are the long rectangle ones. Okay. Now you're not including these because these are your factors. You're talking about inside the actual square itself. So how many tiles of x's do you have? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 of those. 8. I say 8x by 8. And how many unit tiles you have? When I say unit tiles, they just mean just the constant ones. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 of those. All right. So So right below that, it says find the polynomial that represents the product of the two binomial factors. So when we use this part right here, we had this one. These are your two binomial factors. So what they're actually now is to actually write out the answer based off of this. So you have x plus 4 times x plus 4. This is equal to, you want to go in descending order, go in standard form order. So x squared, you have one of those. So you say 1x squared. And you're going to go in the next order, which is just the x. So you have 8 of those, so it would be plus 8x. And lastly, just the constant number 16. Okay. Or if you just want to say this, you can say x squared plus 8x plus 16. All right. Okay. Next question over here says, why do you think we call this the area model? Why do you think we call this the area model? Okay. Well, we call it the area model because we're using the actual formula for the area of a rectangle. Okay. So we call it the area model because we are using the formula for area of a rectangle. It's not always practical to use algebra tiles to represent the area model for multiplication. Why would it not be practical to use algebra tiles to represent the area model for the following polynomial expression? So this is 15x minus 9 times 3x plus 24. Okay. There we go. Why would it not be practical to use algebra tiles for this one? Well, the reason why is because you have 15 of these. You're going to have 24 of the unit tiles. Okay, and then not only that, but remember, the first term that you're going to multiply here is also going to be the first term you're going to multiply here too as well. Okay, so you're going to have 15x times 3x. Right, that's going to be 45 of the x squared tiles. And there's going to be a lot of actual algebra tiles. Okay. So to answer the question for both of these, it is because there would be a lot of algebra tiles for the answer. Okay. In these cases, we could use the distributive property or use a diagram that models the area. Note, the diagrams do not have to be to scale. Okay? So it says use the distributive property to find the product of 15x minus 9 and 3x plus 24. So the distributive property is, let's say you had to multiply both of these, okay? So remember, you're trying to find the product between them. So you're going to have 15x minus 9 times 3x plus 24, okay? So when you distribute, you take a term from the first part and then you multiply it to both terms in the second part, or to all the terms in the second part. So we're going to take our first term here, which is 15x, and multiply it to the 3x, and we're also going to multiply it to the 24. Okay. Now, what we're going to use is, this is going to be one of our properties I've used before. This is going to be the product property. So you're going to do 15 times 3, which is 45. And x to the 1 times another x to the 1, we're just going to add the exponent, so it's going to be x squared. Okay. Then you're going to do 15x times 24. Okay. And 15 times 24 is going to be 360x. Again, this is the reason why we don't use algebra tiles. Imagine using 360x tiles, and that's just for one part of it. Okay. Now you have to now that we're done distributing the 15 to both of these, now we have to take the 9 now and distribute to both of them. Okay. So we're going to do negative 9 times the 3x and times the 24. So negative 9 times 3x is going to be a negative 27x. Okay. And then negative 9 times 24 is going to be negative 216. Now we look to see, can we combine any like terms? Okay, do you have any like terms? Well, this is an x squared. In your other terms, you don't have any x's that are raised to the second power. So this one stays alone, or stays by itself. Here you have 360x and minus 27x. Okay, so those two terms are like terms. The 360 is not a like term with 216, neither is the negative 27x, because they both have an x and only one x, and this one has a constant, this one has two x's. Okay, so therefore you're just going to combine these two terms, and you treat them the same way as you would do regular numbers. So you would do 360 minus 27, and your answer is, I'm going to write it down below here, this is going to be 45x squared plus 333x minus 216. Okay. Now, if that's the case, it says use a diagram to find the product of 3x plus 2y and 4z plus 3y. I don't want you to do that one just yet. You can skip that one. And you guys can actually go ahead on and start doing 1, 2, 3, 4, and 5. Okay? And that'll be it for today. And then you guys should be prepared for the actual class tomorrow. All right. You guys have a good one. Talk to you later.